Well, good morning, physics class. And today we're going to go over your homework that you did yesterday. And actually, this wasn't bad homework. It was mostly plug and chug. I hope you guys found it not to be too challenging because as I was going through it, I was nervous it was a little bit harder than this. It's not. It's fairly straightforward. Chapter review questions numbers 36 to 43 of chapter 20. So what I did this time a little different than I usually do. I'm giving you the answer first. If you got it right, then great. If you didn't get it right, then I'm going to show you how to do it, at least fairly briefly, actually. This one was number 36. What is the resistance of a 1 meter long copper wire with a cross-sectional area of 1 times 10 to the negative 6 meters squared? And so you'd set it up like this. Now to get the rho for this one, you had to go back to page 451, and it's a copper wire, so you can find copper on that chart and plug that in. 1.7 times 10 to the negative 8. The 1 is the length and the cross-sectional area, and you get the answer for the resistance. For 37, it's 1.54 times 10 to the 17th ohms, and this one is a kind of glass that gives us the resistivity. So we plug that into one spot, gives us the length, and gives us the cross-sectional area, and gives us the final answer. The equation, of course, we're using is resistance equals resistivity times length divided by area. So, all right, number 38A was 5.33 times 10 to the negative 7th ohms. Now, we have a volume of this silver. If you make it into a cube, each side is 0.03 meters. And so we use that same equation we did a moment ago. Resistance equals rho L over A. The rho is this is silver, so you go back to page 451, get the resistivity for silver, and then if we're doing a cube, we're running this through the cube, the length of the cube is 0.03 because that's how long it is. Cross-sectional area is going to be 0.03 times 0.03 because it's a square. The cross-sectional area is a square, effectively. Okay, and so that's where those numbers came from. You had to kind of visualize what this cube, length of the cube, 0.03, is the length of the electricity goes through it. The area is 0.03 times 0.03. Okay, for B, the resistance is 4.8 times 10 to the negative 6 ohms. And for this one, they tell us the sample is a bar, and the cross-sectional area is 3 times 10 to the negative 4th. And so you have a long bar. You take the volume, divide it by the area, and you get the other side, which is 0.09. So same resistivity. 0.09 is the length of this bar, and the area is 3 times 10 to the negative 4th. This one is 0.43 ohms. This is a wire, and it has a length, therefore, of 27, and because the cross-sectional area is 1 times 10 to the negative 6th. Okay, so they point out their volume equals area times length. So that's the length is 27 since the area, cross-sectional area is 1 times 10 to the negative 6th. That one was, again, plug and chug, except for figuring out the geometry of those the silver as they plunked it around. Okay, number 39, the answer is 0.450 volts. And they tell us, make sure I'm reading the right one, the current of 1.5 times 10 to the negative 2nd amps flow through a 30 ohm resistor. What is the voltage drop across the resistor? And they give us this is Ohm's law, V equals IR. Plug in the current, plug in the resistance, and you get the voltage. I hope you were able to follow directions. Okay, number 40, the current is 1 amp, and V equals IR. Therefore, I equals V over R. Simple algebra. 1.5 divided by 1.5 is going to give you 1. They gave us, I'm sorry, I didn't read that one to you. 40, a 1.5 volt cell is connected to a 1.5 ohm light bulb in a simple circuit. How much current flows through the bulb? So there you go. 41, the resistance is 1.20 times 10 to the 4th ohms. Now I'm starting with V equals IR again, but I rearranged it to give me R equals V over I. And 41, a 12 volt battery produces a current of 1 milliamp when connected to a circuit to resistor R. What is R's resistance? So there you go. Plug and chug again. 12 volts, 1 point times 10 to the negative third amps. Okay, 42A, the current is 0.5 amps. This is power. 55 watts is power. You remember that all watt is always power. Now, power equals voltage times current. But in this case, we wanted to find the current. So we rearrange it algebraically. The current equals P divided by V. And so the power is 55 watts. The voltage is 110 volts. It gives you a current of half an amp. Then they want to know what the resistance is, which is 220 ohms. Remember, resistance equals voltage divided by current. 110 divided by 0.5 is 220. 43A is 4 volts. By the way, I didn't mention this earlier, and I should have. V equals 4V sounds weird. V stands for voltage. V stands for volts. Yeah, I guess so. Okay, and this is, again, V equals IR. And this one, they have a 40 ohm resistor in a circuit which draws a current of 0.1 amp, which gives us 4 volts. Then they want to know about power. So this is 0.400 watts. Power is voltage times current. 4 times 0.1 is 0.4. Well, there you go. That didn't take long at all, did it? And that's today's class. Hopefully you understood the homework. If not, go back over it. If that doesn't help, you can, of course, contact me either on Discord or on phone. But there you are. Well, have a good day, guys. And tomorrow we'll try to get into the second part of the chapter.